So far, we spent several videos looking at sine of x and cos of x, and we created a scenario in our imagination, a scenario where if you have a circle of radius 1, the height neatly represents sine of x, and sine of x neatly represents the height of this triangle here, and also we created a scenario where cos of x represents the width of this thing here, the width of this thing here, and the width of this thing here neatly represents cos of x. So this thing here is something that we created in our imagination to represent sine of x and cos of x. So rather than when we try and understand sine of x, we would look at the height, and when we want to understand cos of x, we would look at the width of this thing. So as the dot moves around, sine of x changes and cos of x changes. Okay, and remember, so the blue line here represents sine of x. Sine of x always starts at 0. Cos of x always starts at 1. And if you ever forget, remember, this is sine. This here is sine. Well, sine here is the height. So when the dot is at an angle of 0, which is along here, then the height is obviously 0. So obviously 0 here. So this blue line here represents sine. So sine always starts at the origin, and cos. If you look at this here, cos is this thing here, and well, cos when the dot is at 0 angle, is at an angle of 0, then you can see the width here is 1. That's why you start at 1. So remember, cos always starts at 1, sine always starts at 0. And and something to bear in mind, if you shift the sine graph 90 backwards, then the sine graph is the same as the cos graph. Or if you start at the cosine graph and then move it forward 90 degrees, then it would be the same as sine of x. But I will elaborate more on this another time, but just bear that in mind. Now in this video, we're going to look at tan of x. So now it's us looking at this. Y equals tan of x. Now tan of x here, if you get a graph plotter on the internet and plot a graph of tan of x, it will look like this. Something weird happens at 90 degrees here, and something weird happens here. Well, let's try and understand what's going on here. So if you have a circle here, okay, so this is our circle of units, of radius 1 here. Let's just say the dot is right here. So this is our triangle here. Remember, tan is this thing here. Tan is the opposite over adjacent. Okay, so tan the angle is the same, equals 0 opposite over adjacent. Okay, now let's have a look at when the dot is at an angle of 0, so it's right in this position. Remember, tan of x is the opposite over the adjacent. Now the opposite is really the height. Well, the height here is 0. Okay, so the height here is 0, and then the adjacent here is actually 1. So you have 1 here. So when the angle is at 0 here, tan of the angle, tan of 0 will be 0 divided by 1, because if you look at this point here, the height is 0, the width is 1. So you are allowed to have this. In maths, you can have 0 divided by 1, but you can't have a number divided by 0. This here breaks down. You can't have a number, let's say 1 over 0. This thing here breaks down. Okay. Now, okay, so everything makes sense when the dot is here, because you have 0, tan tan of the angle will be 0 divided by 1. Now something weird happens at 90 degrees. Let's say 90 is here. So here you've got, remember, tan of 90 equals opposite over adjacent. Now the opposite here is 1. Well, the height here, the opposite in this case is let's say it's 1. Okay, the height is 1. Now the adjacent here, well, at 90 degrees, the adjacent, which is the width here, is 0 because it's vertical. It's dead on vertical. So so you've got a situation where you have 1 divided by 0. So something weird happens. Well, at 90 degrees, you can't have 1 divided by 0. So you've got what's called an asymptote here along this now. You've got what's called an asymptote. You've got what's called an asymptote right here at 90 here. Okay, so you cannot have it. You cannot have tan 90 because if you have tan 90, you have a situation where you have 1 over 0. So you just can't have that. But you can however have something microscopically close to 90, just to the right, say. So just to the right here, it will be this really steep triangle here. I can't really represent it properly, but it would be a really steep triangle like this, something like this here. Okay, just to the right of 90 degrees. Let's just choose a point just to the right here, and then form myself a right angle triangle here. So in this case here, you have well, just to the right. Sorry, just before you get to 90 degrees. Remember, just to the right of 90 degrees. 90 degrees is here. It's really, let's say, 89.999999. Just to the right. So just to the right is really just to the left on the graph, if that makes sense. Because we are starting here. When we're here, we haven't reached 90 yet. We are approaching 90. Well, let's look at a situation where we're really close to 90. So we are somewhere here. Okay. So here you've got a height of near 1. So yeah, you've got a height. So when you look at the angle here, let's say tan of something that's really close to 90 degrees, 89.9999 here. Okay, equals. Now this height here is very, very big in comparison to the width here. The width, which is the across here, is tiny in comparison to the height is massive in comparison to the width, because you've got a triangle where it's something like this here. The height is massively big in comparison to this thing here. So you've got something that's very, very big divided by something that's very, very small. Now, whenever you have this situation here, very, very big divided by very, very small. So let's select this. Let's say if you have a number that's very, very big, let's choose 99999 divided by a number that's very, very small. Let's say 00 whatever divided by this here. It's going to give you a very, very big number here. It's going to be very, very big. So that's why when it's I know you can't choose 9999. Okay, let's choose something that's near 99. Let's choose something that's really close to 1, but it's not 1. It's just slightly less than 1. So let's choose it to be 0.9999 divided by something that's very, very small, 0.00001. So here, this whole thing here, hang on, let's get a calculator. So clear this, 0.9999 here divided by 0.0000 whatever 1 equals. You see, this number here is still very big. 99. Well, my point is that this thing here would be very, very big. Okay, so that's why when you're near 90 here, this thing here is very big. That's why it goes up right up here. Okay. Now you can't have 10 dead on 90. You can't have 10 dead on 90, but you can have just to the left. Now just to the left would mean that you've gone beyond 90 slightly. Okay. So so just to the left on this diagram would represent just to the right on this graph here. Now let's look at a situation where, well, here you've got a height. Remember, 10 of the angle, 10 of the angle, whatever here, is the opposite, which is the height, over the adjacent, which is the width. Okay, so in this case here, the height here is very big, very big. Oops, big. Okay, divided by the across. The across here, which is the adjacent, is very small. But the thing is, it's in this case, it's negatively small because this is positive 1, this is negative 1. So in this case here, this is actually negative, very small. So now if you have a very big, well, here you've got a fraction where it's very big divided by negative, very small. So that's the same as me moving the negative up here. Okay, how? Let me just tidy this up. Okay, so we've got this at the moment. We've got very big divided by negative, very small. And remember, it's negative because it's on the negative side. This is positive, this is negative. Now, we can move the negative up here, and then we can take the negative out of the fraction. So whatever this thing here, it will be a negative big. It will be a negative answer. So whatever this answer is here, it will be a negative answer because we've taken the negative out. Now, very big divided by very small is going to give you very big. Very big. Okay. Hang on. Let me tidy this up. It's going to give you, well, very big divided by very small. If you don't believe me, get a calculator. Select a very big number. Divided, well, okay, let's do it in our case here, 0.99999 here. Well, it's very big in comparison to the width. Divided by very small here equals this. See, this number is still very big, so I'm just going to call it equals very big, very big. And then, so this bubble here becomes this bubble here, because this number here will be very big. Now, don't forget, we've taken the negative out. So here we've got a very big, but negatively big. So this 10 of this angle here, whatever this is here, is going to be very big, but negatively big. So if you look at this here, just beyond 90 here, it's very big, but it's negatively big. That's why it's miles down here. Okay, and you can use the same argument for 270. 90, 100, 270 is here. You can't have it dead on 290 because you will have a scenario where you have the height, which is negative 1, divided by the across. The across in this case is 0. Here you can't have this. You can't have anything divided by 0. But you can, however, have something to the left and something to the right of it. And you can use the same argument to and it will give you this. It will give you negative. Well, it will give you positively big just to the left, and just to the right of 270, it will give you negatively big. Okay, so your graph or your function, if you like, f of x equals 10 of x here will look like this. Okay, will look like this graph here. All right.